Good afternoon, class. We are looking at pre-calculus practice test number 4, module 4, covering chapters 8 and 9. And here's chapter 9, systems of linear and nonlinear equations. As always, there is a pledge. When we take the exam, we take the exam on our own. A chemistry lab assistant wants to prepare 10 liters of 48% acid solution. In stock, he's got 80 and 40% acid solution. How many liters of each in stock solution should he mix to prepare a 10-liter mixture? So you have to set up a mixture. This is a class of problem more known as a mixture problem. So I have to set up this table. So this is a mixture problem. So 80% solution, 40% solution, mixture, of course, 80% means 0.8. This means 0.48. And when we mix it, we want to get 0.48. Now, we don't know the volume for any of them, okay? And we know that the total is 10 liters, so the total is 10 liters. How much is the volume for each case? How about X and Y? Now, when something is 80%, that is the strength, that means only 0.8 times X is the pure amount of that thing. In this case is acid, so 0.8X here, 0.4Y here, 0.48 times 10, which is 4.8. And that's an equation. This is an equation. So we get the following system. X plus Y equals 10. 0.8 X plus 0.4 Y equals 4.8. Now we can use the substitution method. If you solve for Y here, you get 10 minus X. And you can replace it here. And this is, of course, 4.8. Now we distribute, this remains, this becomes 4, this becomes minus 0.4x, and these two combine into 0.8 minus 0.4 equals 0.4x, and you move this and subtract it from 4, you get 0.8, you divide by 2, you divide by 0.4, and you get 2. So if x is 2, y must be 8. So you say 2 liters of 80% solution and 8 liters of 40% solution. And you have to verify it with this one, because we use, in essence, this first equation to prove that we've come up with the correct answer. So that's pretty straightforward. Now we have a similar question, a mixture problem. How many liters of a solution that contains 15% chemical must be mixed with 6 liters of solution containing 10% chemical to make a solution containing 12% chemicals? We need a table. We have the 15% solution, that means 0.15. We have a 10% solution, that means 0.1. And we have a mixture, which is 12%, that means 0.12. And let's just put in what we've got here, 15%. You have 6 liters of the 10% solution. When we mix them, we get 12% or 0.12. So what is the volume here? We have no idea. How about X? Let X represent the volume that is for the 15%. And the idea of a mixture problem is when they mix, the total volume stays constant, which is X plus 6. That's the idea, everybody. So the product of these 2, 0.15x, the product of these 2.1 times 6, and the product of these 2.12 times x plus 6, they add up, these two add up to become this one. In other words, 0.15x plus 0.1 times 6 equals 0.12 times x plus 6 because we are mixing them up. Now this is 0.6 we're going to distribute. This is 0.12x, and this is 12 times 6, 72. We have two decimals, 0.72. We're going to move things around. That means we're going to move it this way, negative 0.12x. We're going to move it this way. That means subtract it from both sides. That's the meaning of moving. And therefore, 0.03x equals 0.12. This is the same as 12/3 or 4. So we need 4 liters of 15% solution. The table makes it easy to follow. I can't emphasize the importance of that, everybody. A plane can travel 800 miles per hour with the wind and 720 miles per hour against it. Find the speed of the wind and the speed of the plane in still air. Set up a system of equations. So first we define our variables. You can go with x and y, but I find it easier if I go with the initial values in this case. Plane, the speed is p miles per hour. Wind, the speed is w miles per hour. When we go in the same direction as the wind or the current, the speed of the wind or the current will help us, will be added. And when we go against it, it works against us. So they can travel 800 miles per hour with the wind. So P plus W is 800, and against it would be P minus W equals 720. So it's a very straightforward system of equations. These two cancel each other. We get 2P equals 1520. We divide by 2, and P becomes 760 miles per hour. If you put it into any of those equations, the wind would have a speed of 40 miles per hour, and you really want to check it with both, okay? Admissions, tickets to a Little League All-Star game cost $4 for adults, $1.50 for children. A total of 225 tickets were sold, and a total of $500 was collected. How many adult tickets and how many children's tickets were sold? Well, here's the system. Again, it's in essence, it's a mixture problem, okay, because the total number of tickets add up and they are constant. So we are going with adults, children, tickets cost, number, total amount. Here's the total. So the cost for adults, $4, for children, $1.50. Total of 225 tickets, number, the total goes 225 here. And $500 collected. That is the total amount collected, $500. And now, how many adults and children? You can go with X and Y, or just A represent the number of adults, C represents the number of children. It is absolutely your choice. In this case, I think it's a tad faster this way. And so, how much do we collect from the adults? 4 times A here. How much from the children? 1.5 times C. That is the amount collected from each case. So this gives us one equation, A plus C is 225, and this one is the second one, 4A plus 1.5 C equals 500. You can do it by any method. For example, if I want to get rid of the A, I can multiply this one by minus 4, and I get minus 4A, minus 4C, minus 4 times 225 minus 900. And I don't touch the second equation. Therefore, these two cancel each other. And we get minus 4 plus 1.5, negative 2.5 C minus 900 plus 500, negative 400. We divide by negative 2.5, or we can say 4,000 divided by 25 because the negative cancels out the negative. And you get 160. And since they're going to add up to 225, subtract it from that, and A becomes 65. Needless to say, you must check with the second equation because we use the first one to get the missing variable A. One leg of a right triangle is 4 centimeters less than the other one. The area is 70 square centimeters. Determine the length of each leg. So what do we have here? We have a right triangle. This is 90 degrees, and one side is X, one side is Y. We are defining the variables. We know the area for any triangular shape is 1/2 base times the height. At the same time, because it's a right triangle, the sides X and Y are considered. One of them is the base, one of them is the height. So let's go back and read it. One leg of a right triangle is 4 centimeters less than the other leg. So since X is less according to this, so X is Y minus 4. That's the first equation. And of course, half of X times Y is 70. That is the area. The very first thing I want to do, I want to get rid of 1/2. It's a good practice to get rid of fractions when you're dealing with a system of equations. So let's multiply by 2. This becomes XY, this becomes 140. And now we are ready to go by the substitution and replace the X with Y minus 4. So this is Y squared minus 4Y. And I'm going to move the 140. So Y squared minus 4Y equals 140. I move the 140, make it minus 140. This way, I can try to solve this quadratic equation either by factoring or the quadratic formula. Factoring will do the job because you want two numbers. The product is negative 140, the sum is negative 4, and those are negative 14 and positive 10. You can't do that. You can always go with the quadratic formula. Of course, Y is 14, also negative 10. As you know, sides can't be negative. This guy is out. So it can only be 14. So if Y is 14, X must be 14 minus 4 or 10. So in essence, the dimensions are 10 by 14. Okay, the sides. Okay, the legs. And of course, half of their product is 70, as you can easily see. The sum of three numbers is 105. The third is 11 less than 10 times the second. Twice the first is 7 more than 3 times the second. Find the numbers. So what we are going to do, we are going to set up a system of equations and solve. And to do so, we are going to first define our variables. So the numbers are X, Y, Z, or any variable of your choice. However, we have to indicate the first one is X, the second one is Y, and the third one is Z. So the first one is this equation is easy. X plus Y plus Z must be 105. So that's the first. The second sentence. So the first sentence is taken care of. The third, Z is, so Z is equal to. The third, Z is equal to 11 less than 10 times the second. The second one is Y, 10Y minus 11. So the third, that means Z equals 11 less than 10 times the second. Finally, the last one, twice the first, 2x is equals 7 more, 7 plus, 3 times the second, 3y. I hope you see that you can read and translate. So first and foremost, I'm going to call them equations 1, 2, 3, so I can refer to them back and forth. Notice that the third equation has x and y only. The first one has x, y, z, and the second one has given us z. So if I put this one into this first equation, that means x plus y plus 10y minus 11, I can make it a function of two variables. Okay, so x plus y, z is 10y minus 11. Okay, and so I have x plus 11y, and I move the number, and I get 116. And I'm going to call this equation number 4. Equation number 4. So equation number 4 is x plus 11y equals 116. And I'm going to use equation number 3 with that because that has only two variables, same variables x and y, besides equation number 3 has not been used. There are several ways of handling this. One easy way is that if 2 times x is 7 plus 3y, we can multiply this one by 2 and replace it. So if I multiply it by 2, I get 2x plus 22y equals 232. And therefore now I can replace this 2x with 7 plus 3y. So I'm going to replace this with 7 plus 3y. Okay, that's what this is all about. And now I can add these two, I get 25y. And I'm going to move the 7, meaning subtract it from 232, and I get 225. Divide both sides by 25, and you get 9. So we have y, and if we go back to the original equation, we see z has 10y minus 11, so I can solve for z, which means 10 times 9 minus 11. 90 minus 11 is 79. And I'm going to go with the original first equation, x plus y plus z equals 105. I'm going to replace the y with 9, z with 79. I get 88. And take it to the other side, subtract it from 105. And I get x equals 17, and I'm going to write them all. Now, I want to do this with matrices. First and foremost, I'm reminding you of the question and the setup and x, y, z, and the solution. Now I'm going to start with the augmented matrix. To write the augmented matrix, I've got to put everything on the same side except the constant. So this doesn't change. This one, Negative 10y plus z equals minus 11. This one, 2x minus 3y equals 7. First and foremost, you have to put it in a format that can be done. Now, over here, you have a 1, 1, 1, 105. The second one, you don't have x, 0, negative 10, 1, negative 11. The last one, x is 2, okay, the coefficient. 2 minus 3, you don't have z. That means 0. That means 0. And so, and of course, the last number is 7. So we write 1, 1, 1, 105, 0, negative 10, 1, minus 11, 2 minus 3, 0, 7. So pretty straightforward. Now, you can do the matrices and Gaussian reduction, or just put it into a matrix and do REF, row, reduced row echelon form. And as you can see, the last column is the answer. So a quick recap, the way it's given, it's not going to work. You have to change it in this format and then use the augmented matrix and do reduce row echelon. Jay borrows $25,000 to pay for a remodeling. He borrows some of the money at a bank that charges 8% interest. At the second bank, he borrows $2,000, more than half the amount borrowed from the first bank. The interest rate at the second bank is 10%. The balance of the $25,000 is borrowed from the third one that charges 9% interest to be paid. The total annual interest Jay pays for the 3 loans is $2,220. How much does he borrow at each rate? A system of equations, and we have to go with the system of equations and a table. And again, in essence, again, it's a mixture problem. And it's a mixture problem because we are adding the total amount that is a constant, and it's $25,000. So we have bank number 1, bank number 2, bank number 3. The first one charges 8%, the second one 10%, the third one 9%. 8%, 10%, 9%. So how much does he borrow? The amount borrowed, the total amount is 25,000. It goes in here. How much is the total interest? And I'm reminding you of the simple interest. I equals PRT, the amount of principal times R times T. And T happened to be 1 because we are looking at an annual interest. When we say annual, that means in 1 year. That means T equals 1, everybody, okay? And so how much is that? 2220. That means the total right here. Now, how much do we borrow from each? I don't know. X, Y, Z. X amount, Y, and Z. As I mentioned, you just make up your own variables, okay? Anything that you like. But the bottom line is you have to define your variables and do the job. All right, so now how much interest? I is PRT. The amount of principal is the amount of money borrowed, times R is 8% and T is 1. So just multiply this column by this column. So you get 0.08x, 0.1y or 0.10y, 0.09z. This is the 3 that we get. So the equation number 1 comes from here. X plus y plus c is $25,000. Now, I hope you see this is another equation that is really the last one, 0.08x plus 0.1y plus 0.09z equals 20. But let's read this. At the second bank, that means over here, because we said y is for the second. At the second bank, he borrows $2,000 more than half the amount borrowed from the first one. So y is half of the first one plus 2,000. Y is half of x plus 2,000. He borrows 2,000 more than half the amount borrowed from the first bank. And finally, 0.08x, 0.1y, and 0.09z is 22. Okay. The very first thing we want to do, we want to get rid of all the decimals and fractions and otherwise. So clearly, this is fine. This one we're going to multiply by 2. We get 2y is x plus 4,000 because we don't want to have fractions. And this one, I hope you see that we're going to multiply by 100, right? Because we have 2 decimals. And so we have the first one, we have the second one, and this one becomes 8x, 10y, and 9z. They add up to 2 zeros, 222,000. So this is the system. Again, we're going to call him 1, 2, 3, so we know which equation we are discussing. Notice number 2 has 2 variables, x and y, so that's good. So using 1 and 3, we get rid of z, then the combination becomes a combo of 2 variables, x and y. So how do we do that? So ignore number 2, ignore number 2. Let's use 1 and 3 to get rid of z, and obviously one easy way, if you multiply this one, because this is plus 9, make this minus 9 multiplied by minus 9. So use equation 1 and 3 to eliminate z. So what do we get? Minus 9x, minus 9y, minus 9z. And this one times 9 is 225,000 negative 225,000. And number 3, we just write it unchanged. Clearly, these two cancel each other. These two minus x. These two plus y. These two minus 3,000. So we are going to use equation number 2, and we're going to call this equation number 4, and we use equations 2 and 4 to eliminate x. So we put them next to each other. By the way, you may notice you just subtract one from the other, you get rid of x. But in any event, let's multiply one of them. It doesn't matter which one, by -1. So let's say you're going to multiply this one by -1, and you get x minus 2y is minus 4,000. So if you add them up, these two cancel out. These two add up to negative y, these two add up to negative 7,000, so y must be positive 7,000. So you use one of the original equations, obviously number 2, because we have y, we can find x. So minus x plus 2y, that means minus x plus 2 times 7,000 is 4,000. This is 14,000. And subtracted, you get minus 10,000. So x becomes positive 10,000 because this is negative. And now we use one of the original ones. Obviously, the easiest would be 1. They add up to 25,000. So 10,000 plus 7,000 plus what number is 25K is 8,000. And we write J borrows 10,000 at 8%, 7,000 at 10%, and 8,000 at 9% interest. Now, we could use, of course, I just wanted to show you step by step how it's done, and we can use the augmented matrix and so forth and come up with the answer. The augmented matrix 25,000, minus 1, 2, 0 because he's missing 4,000, 8, 10, 9, 22,000. Okay, that's the matrix. And if we do RREF, reduced row echelon form, as you can see, the last column is the same answer as we got. Use partial fractions to decompose. What are we talking about? We know how to add rational functions. That means how to add fractions. The reverse process is called partial fraction decomposition. Partial fraction decomposition is used when we have a fraction p of x over q of x, where p and q are polynomials, and the degree of p is less than the degree of q. I can't emphasize this enough. If it's not, we have to make it so. Okay, by dividing. Note, if the degree of the numerator is larger than the denominator, then perform long division first. Even when it's equal, you should do that. So what happens? Case 1, you have distinct really linear factors. So you have a bunch of factors, all of them are linear and all of them are distinct. So you write the original function, for example, 3x over x minus 1 times x minus 2. And you write it as something over the first one plus something over the second factor all the way to the last one. So in this case, we write a over x minus 2 and b over x minus 1 or vice versa, doesn't matter. And we work it out, it ends up being 6 over x minus 2 minus 3 over x minus 1. I will show you by looking at a couple of examples, but the idea is that the denominator has only 2 factors and they are distinct linear functions. Degree is 1 for each case. Now, if Q has repeated linear functions, okay, for example, be repeated R times, then instead of single term of A1 divided by that, we have one term for each successive power in the denominator. In other words, if you look at this case where we have the same linear function but to various powers, for example here, 3x plus 1 over x minus 1 quantity squared x minus 2. Okay, so we put a over x minus 1 plus b over x minus 1 squared and then c over x minus 2. You do the job. Doesn't matter, how they came up with the answer. We will look at it, but that's the concept. And number 3, Q has some irreducible quadratic factors not repeated. If you look at this one, if we can't factor, look at this example. We have x minus 1 times x squared plus 1. I hope you recognize x squared plus 1 cannot be factored. So for x minus 1, you write a over x minus 1. For x squared plus 1, you write bx plus c over x squared plus 1. In other words, this is degree 2. The numerator must be degree 1. Please understand a has degree 0 because it's a constant. And if it repeats, if this thing repeats, for example, this one again, the denominator is x minus 1, you write a over x minus 1. Okay, and you end up with the answer. For x squared plus 1, you put bx plus c for x squared plus 1, and then cx plus d for the second one because it's being repeated. So what do we mean by this? Let's find out. Use partial fraction to decompose. Case 1, the denominator q of x is a product of distinct linear functions x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x. The very first thing we do, we factor the denominator first and foremost. So we want to decompose it. You can take the x out and you get 2x squared plus 3x minus 2. 2 is a prime number, so it's x and 2x. So is this one is 2 and so x and 2x. This is 2 and 1, one of them negative. I'm assuming everybody can factor things. And to be on the safe side, all you have to do, take a look. Okay, so this one is minus x, this one is plus 4x, they add up to 3x. In other words, what you want to check is the middle term. Let me, it's a different color. So this gives you minus x. This gives you 4x. They must add up to the middle. So you do write the numerator over this factored format. And as you know, there are 3 factors. All of them are linear. So a over x, b over 2x minus 1, c over x plus 2. That's when it's linear. Now, if we multiply both sides by LCD, which is this one, what happens? Well, the left side just becomes the numerator. Let's discuss the right side. A, because this is x, a times 2x minus 1 times x plus 2. B times x plus 2 plus c times x times 2x minus 1. I hope you see that if you multiply by LCD, which is this denominator, this is what you do. Now, let's multiply these two. We get 2x squared, and then we already have that actually. It's 2x squared plus 3x minus 2 for this one. This one, so it's a times that. This one is b times x squared plus 2x. And finally, c times 2x squared minus x. Okay. Now, what I want you to notice, on the left side, I didn't put x squared, I put 1x squared. I want to emphasize the coefficient of x squared is 1. The coefficient of x is 2. The coefficient of the constant is negative 1. So we are going to collect like terms and then put their coefficients equal. So x squared times 2a plus b plus 2c. X times 3a times 2b minus c. And then none of them has a number except the first one, minus 2a. So what I'm doing is elementary algebra. I'm collecting like terms, something times x squared, something times x, and then the constant. So if you look at x squared, this is 1. So this must be 1. This is 2. The coefficient of x must be 2. Minus 2a must be minus 1. So I hope everybody is following that. Now, obviously here, a is 1/2. Then you can put the 1/2 here. You get 1. You put it here 3/2, and you can solve for b and c. And I'm going to leave it for you to solve. And you get b is 1/5. C is negative 1/10. And so we are going to go back to this one and say the original one is a over x. That means 1/2 over x, b 1/5 over 2x minus 1, and c minus 1 over 10 over x plus 2. So it's pretty straightforward, everybody. I hope everybody is following that. Okay. There is another way that you can solve it. We'll discuss that in a moment, but um, in the next page, it's called Heaviside. So use partial fractions to decompose. We already have done that. Okay. And we want to look at this methodology known as Heaviside method. We already have done it. We have the answer. So as you recall, where we had x squared or 1x squared plus 2x minus 1 equals 8 times 2x minus 1 times x plus 2 bx times x plus 2 plus cx times 2x minus 1. What did I do? I collected like terms, right? For example, this ended up being 2a plus b plus 2c times x squared and so on. And I set it equal to 1 for the coefficient of x squared is 1. I did the same thing for x, the same thing for the constant, and I solved a system of equations. Perfect. But we can also take the easy way out. The easy way out is this. You see, this one involves x, and this one involves x. So if I use x equals 0, these two pieces go to 0. If I use x equals 0, okay, this becomes 0, this becomes 0, minus 1 equals a times minus 1 times 2. This x makes it 0, this x makes it 0, those two go away, and obviously minus 2a. And a is 1/2. Okay, so again, this is one methodology that is going to make it nice and easy. Then I'm going to go back to this one and say, okay, so I used x equals 0 and I could get a. What else can I use? Well, this has 2x minus 1, this has 2x minus 1. So what I did, I set x equal to 0. If you set this one equal to 0, everybody, x becomes 1/2. So that means if you plug in 1/2, this goes to 0, this goes to 0. So you have to work this one out and this one out. So for x equals 1/2, the left side would be 1/2 squared plus 2 times 1/2 minus 1. The right side, this has 2x minus 1, goes to 0. This has 2x minus 1 goes to 0. This is b times 1/2 times 1/2 plus 2. So a quick recap. I want to make sure everybody understands what's happening. Because x equals 1/2 results in 2x minus 1 being 0, okay? So when I'm here, this goes to 0 and this goes to 0. I evaluate the rest of it at x equals 1/2. That's what happens, everybody. And I hope you see that 1 and minus 1 cancel each other. This is 1/4. This is 2 is 4/2, so this is 5/2. And 1/2, the product is 5/4. And so that means they cancel each other. 1 is 5b and b becomes 1/5. Now, just for the sake of argument, if you have no other choice, let me just erase my book. If you don't have any other choice, all you have to do in the original one, plug in the values of A and B and calculate the missing value of C. However, we notice that, you see this one, if I set this equal to 0, x becomes minus 2. And if I do that, if I set x equals minus 2 here, for this one, everybody, this goes to 0 because of x plus 2. This goes to 0 because of x plus 2. So this goes to 0 because x plus 2 is 0, right? X is minus 2, and so does this one. So I hope everybody is clear on that. So let's do that. So let's see what happens when we do that. Let me erase my work, everybody, so it becomes clear what is. Or we can keep it. Okay. So this one is x squared minus 2 squared plus 2 times minus 2 minus 1. This is no good. This is no good. C times minus 2 times 2 times negative 2 minus 1. So let's see what we have. This is positive 4. This is negative 4. They cancel each other. So the left side is negative 1. And this is minus 1. This is minus 5 times minus 2 is positive 10. So C becomes 1 over 10. So I hope you see that the methodology that I just went over can be really helpful in a lot of cases to speed up the process. Case number 3, Q of x contains irreducible quadratic factors, none of which is repeated, 2x squared minus x plus 4 over x cubed plus 4x. The very first thing is to factor the denominator to see what we have. And that is x times x squared plus 4. So this equals something over x plus bx plus c over x squared plus 4. We are going to multiply both sides by LCD, which is x times x squared plus 4. And on the left side, we get the numerator, 2x squared minus x plus 4. On the right side, a times x squared plus 4 plus bx plus c times x. Again, if you want to collect like terms, see, I put 2x squared and I put, instead of minus x, I'm putting minus 1x, meaning the coefficient of x is minus 1. So this is a times x squared. This is, I hope you see as bx squared. Maybe I just write this ax squared plus 4a plus bx squared plus cx. This is a very simple set of, system. When we collect these two, we get a plus b times x squared. And the other two, we just write them. So a plus b must be 2. C must be negative 1. 4a must be 4. And clearly this one says a must be 1. If a is 1, b is 1, of course, because they add up to 2, and c is negative 1. So we're going to plug in here. We're going to replace the a, b, and c accordingly. And the final answer, 2x squared minus x plus 4 over x times x squared plus 4 is 1 over x plus x minus 1 times x squared plus 4.